Having spent a few minutes looking at the for loop, this is a thing where you'll really have to spend 10 or 15 minutes really playing with it, getting the syntax down and memorized. I want to show you some quick for loop variants. There are four of them. The first one that we're going to look at is the default, which is to say that we've got for, we create and initialize a counter, a semicolon, our Boolean conditional, a semicolon, then our counter increment or decrement, close parentheses, and so on. That's the default, and it works just fine. We've already seen this one. The first variant, the first real variant that we might look, variation number 2, I guess, variation number 1 is the default. We remove the incrementation, which normally hangs out inside the loop declaration, but we're just going to move it down to the very end. Okay, and so when we take a look at that, here's our here's variation 1. Then we'll take a look at variation 2. All that we've done is take the counter, which normally goes right here, and we've moved it down to the end. And this will still work. The thing that Java cares about is that we have those two semicolons in there, and that between the semicolons and I guess and then within all that, everything is of the type that it's supposed to be. That is to say, we have something that we do before the loop starts, we have something that we do at the beginning of each iteration of the loop, a Boolean conditional, and then we have, in this case, something that we do at the end of each pass through the loop. So we'll save and quit, we'll compile. When we run this, we'll see two things. We'll see variation 1, which goes from 0 to 196, and then variation 2, which goes from 0 to 196. And the difference between variation 1 and variation 2 is primarily that our increment is moved from inside the for loop declaration down to the end of the for loop. So it's not too big of a difference. Certainly not too bad. Now we can take a look at variation 3, wherein we take our counter declaration right here, and instead of having it in the for loop, we have it just a little bit before the for loop. So variation 3 is neat in that it lets us keep this counter after the loop is done ordinarily because of the way that block scope works. And that's a thing that we'll talk about here in the next lecture. As soon as we get down to the end of the for loop, our counter is obliterated. In this case, though, we can keep our counter even beyond the conclusion of our loop, which is kind of neat. So we can take a look at this guy. We can save and quit. We'll take a look at variation 3. And with variation 3, we still get that 0, that's 2, that's 4, that's 6 squared, 8 squared. Let's take a look back at that, because that doesn't quite go the way that should. Here we go. The problem with variation 3 is that we have this I++ in there. Okay. My apologies. Okay. So with variation 3, this is the one where you declare our counter outside of the for loop. We still get 0 through 14 squared, one line at a time. As we swing down a little further, we can take a look at variation 4, which tasks us with moving our condition, right? Our condition normally goes right here. We have 4, and I is equal to 0, then a semicolon. Normally we would put our condition right here, but in this case we're not. Another semicolon, and then our increment. And we're going to take our condition, and we're going to move it down below using a break statement. And break, we'll talk about the break keyword when we look at, in our very next lecture, when we look at the break keyword, the continue keyword, and the and block scope. But what it basically does is it just ends the loop. When we say break out of the loop, go down to this closing curly brace. So we don't have to necessarily have a Boolean condition here. We can handle the exit from the loop some other way if we feel so inclined. This is generally bad practice, but I want to show you that we can do it. In this case, with variation 4, we get the ability to run through our loop without any real worry of things breaking. The last variation that I want to show you we're just using these multi-line comments to move through these variations. The last variation that I want to show you is what we can call the empty for loop. So here's our loop declaration. We have for space, semicolon, space, semicolon, space. The empty declaration loop. This one's going to be a little screwy. So we still have to have a counter. We still have to have our increment, or we still have to have our condition, I'm sorry. And then we have to have our increment. And so in this case, though, that means that we have nothing inside the loop body. Which is alright, it's just going to make things a little bit screwy. But it's still going to work. As we see right here, variation 5, where nothing works the way that it should. Except it all does. The end user doesn't see the difference. But if we look, I want you to think about all of this, right? All that extra work that we have to do, as opposed to looking back at variation 1, just these really 4 lines of code, 3 lines of code, depending on if you count this closing curly brace as a line. Which is to say that the for loop, if you feel so inclined, you can really make this an agonizing process. But if you use it the way that it's meant to be used for counter-controlled repetition, which is to say, inside your loop declaration, you create your counter, you have a Boolean conditional, and then you have your increment or decrement, as the case may be. Life gets pretty okay. Life gets remarkably okay, in fact. Okay. So some different things that you might see. You might see the increment get moved from inside the loop declaration down to the end. You might see the counter initialization and declaration getting moved from the for loop all the way up to the beginning, right before it. You might see the conditional, that middle conditional, which normally goes right here, getting moved down into the middle of the for loop with a break statement. And we may see something really screwy like this, wherein everything that we might want to do with this particular for loop is broken out into tiny little pieces. And again, the easiest way to handle all this is to actually just write your for loop the way that they're meant to be written. Now with for loops, so here are some quick best practices that I'd like you to keep in mind. The very first one is that when you're writing loops, you can use a while loop for everything. And you can, with a bit of work, use the for loop for pretty much everything. But what I'm going to suggest, though, is that you only use the for loop for counter-controlled repetition. That's to say, you only use the for loop when your program has to do some task some specific number of times. And it doesn't really matter if that's a number of times that is determined by the user, or that's determined by the program, or that you determine as you are writing the software. That doesn't really matter, but only use the for loop for counter-controlled repetition. And the second best practice is, unless you absolutely have to, write the for loop declaration the way that it's meant to be written. That is to say, something that looks like this, where you've got your counter declaration and initialization, a Boolean conditional, and then the counter increment or decrement. As much as you can, write the for loop the way that it's meant to be written, and use it the way that it's meant to be used unless you have a remarkably good reason to do otherwise. And then finally, if ever you're not sure that a for loop is correct, or if you're not entirely sure even how to write a for loop, you can always use a while loop. One of our very next quiz will probably require that you write a for loop, but generally, you can almost always use a while loop. And by almost always, I mean you can always use a while loop. I know professional programmers who exclusively use while loops simply because that makes the syntax, that makes their practice a little bit easier, and because they're more comfortable with that. There's never, ever, ever going to be a situation wherein you will have to use a for loop instead of any other loop, except perhaps on a quiz. In general, though, use the for loop for counter-controlled repetition, and that signals to other programmers with whom you are working that what you are doing right there is counter-controlled repetition instead of sentinel-controlled repetition or something else. Okay, when we come back, I'm going to show you the do-while loop, which in this particular class we use mostly for input verification and input validation. See you in a bit.